Is it appearing recording?
Yes.
Yeah. Shiva, you show your PPT on your demo, current demo.
Yeah. So I think it is visible.
Yeah.
The screen is visible.
Yes.
So today we'll discuss about our two-tier architecture with WordPress and MariaDB in a manual method and as well as infrastructure as a code with Terraform script.
So manual method you are going to discuss, but you are not going to demo the manual process, but you
Yes, of course.
will show only Terraform script execution, right?
Yes.
Okay, go ahead.
So these are the requirements which we need to execute in a manual way. So first of all, we need to set up a WordPress blog site for Office in a new VPC environment in our AWS console. So once we set up the WordPress blog for Office in a new VPC, then next we need to we- the WordPress blog site should be hosted on the one web server and MariaDB database for database with MariaDB it should be installed on the another server. So WordPress can be reached from the any IP address, so that another machine or another can access this WordPress. And WordPress and database should be connected with the most secure way to avoid the security issues. And we need to allow the ports to connect to the WordPress and database server via gem server only. So and finally we need to updating and patching in both servers at the same time, and it should be more secure way via the internet. So at last I will show in this demo with the Terraform script. So we install the WordPress, the Terraform script. So basically this is the architectural diagram of our two-tier architecture. So in this is the tier 1 and this is the tier 2 where in tier 1 we need to install the two servers in the public subnet, and in the private subnet we need to install one DB server. So we can able to connect from the DB server to the internet gateway via the NAT gateway. Okay, so we can't able to directly connect from the DB server to the internet gateway, but in the public subnet we can able to directly connect to the internet gateway to go to the outside world, so connect to the customers. uh, so these are the prerequisites in a manual way. So first we need to take one IAM user, then we need to install and configure in our local, and also we need to install a CLI and configure in our local. So after that these are the tasks which we need to perform in a manual way. So first we need to create VPC, then we need to create subnets also, private and public, and also for routing we need to create a public and private. So after that we need to associate the public subnets and public and private subnets to the route table. Okay, so then later we need to create one internet gateway and attach it to the VPC because the route, so it will route to the outside of the world, since we need internet gateway, and modify the public route table to internet gateway. Then we need to create one NAT gateway, and it should be modified private table to the NAT gateway. Since the database is in a private subnet, so it should talk to the NAT gateway, and via NAT gateway it will go to the internet gateway. So that's why we have created NAT gateway with the private route table. So later we need to create a security group for gem server, app server, and as well as DB server. So after creation of security groups, we need to create one EC2 gem server and just to disable the source and destination check for the security purpose. So later just log into the gem server and you need to set up the SSH key for login to the app server as well as DB server. So once we have set up the SSH key for app server and DB server, let's log into the database server via gem server and install the MariaDB. So to give access to the user who can connect from the app server. So and also we need to install the EC2 app server to install the WordPress. So once we have done all those things, then we need to set up the WordPress for DB connection itself. So once we have successfully completed the WordPress setup for the DB connection, then we can validate by in a browser with WordPress blog by creating the first blog. So finally, we need to create a WordPress application with the Terraform as infrastructure as a code script. So these are the tasks manually. So now with the automation script. So these are all the manual scripts. So see, so we need we need to automate the previous process with the infrastructure as a code. So I created the folder structure as like this. So for provider version provider, I'll take one folder, and for creating VPC subnets and all the resources in our AWS, so I created each one of the folder. So let's get into the each one and folder. We'll discuss within detail. So our folder one is version of provider.tf. Okay. So okay, I will explain with the AWS console also. Okay. The first one is version provider.tf. So I made a file with version provider.tf. So in the provider.tf file, so we need to first provide the which cloud you are associated with, whether it is AWS or GCP or Azure. So now all the resources are installed in AWS cloud. That's why I have given AWS cloud provider, and the source is Ashiko Terraform. So next I need to give the region also. So for that I have considered I have just passed the variable, that is variable.aws region, so that you can reuse this wherever you want in the other regions also by using variables. So for creating VPC, so the resource is AWS VPC, and I named it as the main. So this is CADR block. We need to consider. So variable.main VPC CADR, and I will go with the default tenancy. See, the same thing here is if I want to create manually, see, first I will give name VPC, then I will go with the IPv4 CADR, right? So in the similar way, I'll just consider it as a CADR block name and the default. The same thing here, the tenancy. So this is the option. So just click on.
You don't need to show the console screen. Just explain the code only. That's enough.
Okay.
Because
So
later you are going to show the resources, right? Created resources.
Yes.
Okay, yeah, please do that.
So on the consider, I'll give a tag name is VPC. So next one is to create the public subnet. So I'll take the resource AWS subnet and I name it as the public subnet. So because subnets are associated with the VPC, so VPC ID is equal. So AWS VPC dot main dot ID. So this is the VPC which you have connected with the public subnets inside the subnets. So the CADI block for the public subnet is, I consider it as a variable dot public subnets. So you can choose that one. And it is available zone is US East 1A, and the tag name is VPC public subnet. I have given the public subnet, VPC public subnet. So for creating a private subnet, so just to take a resource AWS subnet, and the name is the private subnet. Since the private subnet is also connect inside in the VPC, so VPC ID equal to AWS VPC dot main dot ID. So it has also CADI block IPv4. So I consider it as the variable dot private subnet since it has the same availability zone. So and I have given the tag name is VPC private subnet. So that is the second VPC subnets. The third one is we need to create a public and private route table to connect to the subnets. So I have taken the resource AWS route table. So since this is a public route table, I named it as public route table. So you need to connect with the VPC. So that's why VPC ID equal to AWS VPC dot main dot ID. So this is I don't have required right now. So I and the tag name I have given is VPC public route simply. So this is for private route table. The resource is AWS route table, and I named it as private route table. So since it has inside the VPC, so the VPC ID equal to AWS VPC dot main dot ID, and I have given the tag name is VPC private route. So after that, we need to associate the route table with the public subnets as well as in private subnets. So for the public subnets, we need to associate it with the AWS route table association. So for that, I have created the resource AWS route table association with the public route association. I named it as public route association. So since it has to be mentioned subnet ID, so it should be required to connect to the subnet ID. So that is AWS subnet public subnet ID. So we will associate it with the public subnet with this ID. And the route table ID is AWS route table and public route table. Since it has connected to the public route table, so that's why I have given this one. Similarly, we can follow the same here for a private subnet. So the resource name is the private route association. So since it has the subnet ID, AWS subnet, private subnet ID, and the same route table, we have to connect. Say AWS route table, private route table. So the next one. So we need to create internet gateway in order to go to the outside of the world, connect to the outside. So for that, I need to create internet gateway and attach it to VPC. So first I need to create an internet gateway. So for that, I'll create a resource AWS internet gateway, and I give a name as internet IGW. Then it should be connected to the VPC. So that's why VPC ID equal to AWS VPC main ID, and I have given the tag name is VPC public internet gateway. So the next one is I need to add the route to the public route. Since so it should be go to the public world, right? So I have created the resource AWS route, and I consider it name as a public route. So it should be required the route table ID. So I have given the AWS route table public route table ID. So the CADR block is 0.0.0. Since it has the public route table to connect to the internet gateway, have given the 0.0.0. So and it should be in the get internet gateway. So it has to connect to the internet gateway. That's how I have given internet gateway dot id. Same internet gateway dot id dot double id. So next I will create one key pair in the Terraform script. Like, so first we need to generate a secure private key. So and we can encode it as a PEM file. So for that I will take a resource private key with the key pair name, and this is the algorithm. Okay, so next I need to create the key pair. So the resource AWS key pair, and I name it as a key pair, and we need to give the key name and public key for creating the key pair. So that's why I have given the key name is Linux key pair, and it has the public key. So I'll just take private key dot key pair dot public key open SSH. And now we need to save the file. In order to save the file in our local so this is the resource local file, and I name it as SSH key. Since it has the file name, so we can consider it as a variable AWS key pair dot key pair key name dot pem, and it has the content I have stored in the content variable. So TLS private key dot key pair dot private key pem. So this file I have stored in the content. So now we need to create the NAT gateway. So first we need to create elastic IP to attach to the NAT gateway. So that's why I have taken the resource AWS elastic IP, and I named it as NAT gateway elastic IP. So VPC, since it has inside the VPC, so it is a true. I have given true, and I named it as the tag name is VPC NAT gateway. Now I need to create a NAT gateway using subnet ID and allocation ID. So the resource is AWS NAT gateway, and I name it as NAT gateway. So the allocation ID is elastic IP, because I need to allocate the elastic IP to the NAT gateway. So sometimes if I restart, so the elastic IP is same as in the NAT gateway. So that's why I have attached to the elastic IP to the NAT gateway. And the subnet ID, so we need to assign the subnet ID one, that is AWS subnet public subnet. So we need to assign one public subnet to the NAT gateway. So that I have given the tag name is VPC NAT gateway for the internet gateway. So for next, this is the security group file. So here we need to create security groups for all the servers which we have created in our with the help of Terraform. So I have taken the resource AWS security group with the help of name VPC gem server, and I name it as a VPC gem security group. So I need to allow only SSH and ICMP from anywhere. So since it has in the VPC inside the VPC, so I need to give the AWS VPC main ID. So these are the rules, inbound rules, which we need to allow the ports 22. Allow SSH from everywhere. The port from 22 to port 22, and it has the TCP protocol. So since the allow SSH from everywhere, so we can give the block CADL block is 0.0.0.0. And the next one is another inbound rule is allow ICMP from everywhere. So it has a port number -1 to port -1. So since it has allowed from everywhere, so we have given 0.0.0.0/0, and I have given tag name is VPC gem server group for the security group, this one. So for the next app server security group, so I have named it as a VPC app server security group. So and I need to allow SSH and ICMP from gem server, and allow IT and 443 port from everywhere. Since it has the application server, so we need to connect to the gem server. That's why I have given SSH and ICMP from gem server. And since it has the it has in a public server, so we need to allow 80 and 443 from everywhere. And I have given the VPC inside AWS VPC.main ID. So coming to the inbound rules, and so I need to allow the inbound rule HTTP. So the port number is 80 from port to 80. Okay, so the protocol TCP, since HTTP from everywhere, so I have given 0.0.0.0/0, and the another port in inbound rule is HTTPS. So it has the 443 from port to port, and TCP, the CLI black is everywhere. The next inbound role is 22. So we need to allow SSH 22 port number from gem server. Okay, so from gem server, you need to assign that AWS security VPC gem server to security group. And also we need to allow ICMP from everywhere. So this is the from port to port. This is the protocol ICMP. So it means everywhere means we can give 0.0.0/0. So this is the outbound rule. It allows all IP to connect to the outside world since it has from port 0 to 0. So it is CLI block 0.0.0.0. So it will go out into the public outside of the world and connect to the internet. So this is the last our security group, DB security group. So if I want to connect to the DB server, so this is the security group I need to follow. So for this, I need to allow 3306 port number, MariaDB port number of MySQL. Okay. Yeah, 1 second. So this is the inbound rule. So we can allow 3306 from app server. So it should allow only 3306 from app server. So that's why from port to port, and I need to assign the AWS security VPC app server to the security group. And another inbound is SSH from gem server. Okay, since it has the DB, so we shouldn't allow from the anyone. So we need to allow SSH from gem server. So the port number is 22 port number, and it has to be allowed from the gem server. So since we also allow ICMP from everywhere, so that's why we have given from port to port, and we need to, since it is from everywhere. So this is the for outbound rule, allow all IP address to the outbound since it has connected to the outside of the public internet. So now I need to create one gem server. So for that I have created resource AWS instance and I named it as a VPC gem server. So since I have to create EC2, so for that I need to one AMI. So I have taken this Ubuntu 18.04 AMI, and I need to take one instant type also. So that I have considered it as a variable.linux instant type. So I have stored in the variable, and I need one key name also. So that why I have taken this AWS key pair key name, and since it has one subnet ID. So that's why that I have assigned it to the subnet public subnet ID, because gem server is an open for all, so that's why I have taken public subnet ID. So I need to assign security groups. So in previous we have created a security group for gem server, so that's why I have assigned the security group VPC gem server ID to the security group, since it has the available region same US East 1A. So we need to associate public IP address is equal to true. So if we give false, it has so it won't appear the public IP address while installed in gem server. So I need to here I take one user data bootstrap just and I have named it as a gem server. So for MariaDB server, I'll take the resource AWS instance VPC dev server. Since we need to create one DB server, so for that we need one AMI and also one instance type. So one key name also and one subnet ID, and as well as a security group and available region. So all the parameters are needed to create the server. Okay, so and I have given the bootstrap file also, so that this is the file. So we need to update inside the server, as well as and we need to install MariaDB server, and we can change the actual network to the server configure, and we need to start the MariaDB servers, and I named it as the VPC dev server. This is the app server. So I just have created resource AWS instance VPC web server, and the similar way I have created in the apps DB server as well as in the gem server. Similar way I have created the app server with the AMI instance type, ename and subnet ID, as well as security groups, available region, and public IP address. Since it has a user data file, so I have updated and upgrade the server, and then I need to install the Apache 2 and PHP MariaDB client to connect to the DB server. So that's why I have installed, and later I'll create and copy the default configure to the WordPress configure, since I need to install WordPress block. So that's why I have configured this one. Next I will change the WordPress configure file, and I need to enable the WordPress configure file and disable the old default configure file. Since I have to affect the changes, so I need to reload Apache 2. So after successfully install WordPress, we need to give the URL from the web. So it will enter the zip file, and it will give the permissions to the variable www.data WordPress. So this is the bootstrap while executing inside the server app server. So this is the output.tf file. Have just assigned with the values. So this is DB server public IP, and I assigned it with the instance VPC DB server public IP. So all the three servers I have configured the public IP as well as private IP with the web server public IP, web server private IP, as well as gem server public IP, gem server private IP, as well as DB server private IP, DB server public IP. So and I configured it as output.tf file. After created, it will show. So this is our Terraform variables, and the first one is the VPC. So for VPC, I have configured the 10.0.0.0/16, and I need to connect to the public subnet, so I'll take the 10.0.1.0/24, and also private subnet similar way 10.0.2.0/24. So, and I need to configure the instance type, that is T2 micro variables. So these are the variables, and for the configuring the variables in the with the parameters, that is AWS region. So this is the users east one, and these are the variables. So this is the config I have assigned with the values. So now we need to execute the Terraform commands. So before going to the Terraform commands, so I have written the script in my local. So let's go to our script. So I have, yeah, I have here. So I have the script here. So once we have the script in our local, just go to command prompt. So you need to change the directory from current folder. So I just copy and paste here to the current folder. Okay, just click on enter. So now I need to configure the AWS. So I need to give the key. So for that I have in my local. So let's go. So this is the access key. So just give here. So you need to give secret access key. So click on enter. Since it is in the US East one, so I'll go with so I have default format name, so I have given. So once we have configured our credentials, now so we need to execute our commands. So the first one is Terraform. So once we execute the Terraform init, so in the backend itself it will initialize, and whatever the plugins required, it will install. So now the Terraform has been successfully initialized. So now we need to execute Terraform actual plan. So whatever we have configured in our Terraform files, it will execute with the help of this command. So these are the resources which we have configured in our Terraform files. So now we need to execute Terraform apply. So with the help of this command, so all the resources have created in our AWS. So just give yes. So it is creating one by one. So it will take some time. So, so still all the resources are creating.
Parallelly, you can show console, the resources, and VPC. Go to VPC, first VPC should be created, right?
So
You
this
can show
is
those components.
when VPC. So next go to subnets. So this is the when VPC public subnet, and the when VPC private subnet is also created. So go to route tables.
Gateways, NAT gateway.
Yeah. Okay. So this is public internet gateway.
After that,
So this is NAT gateway.
then go to groups.
So this is app server. This is gem server. This is DB server. So we'll
How
go
many
to
EC2s are there now?
yeah, for three security groups, we have three servers. So I'll check. So since actually we have installed three servers in a manual purpose. See, this is when VPC gem server, when VPC DB server, and when VPC web server. So actually these are servers which we have created previously. I think for manual.
Can you show the architecture diagram, these servers where they are sitting, in which subnets? Go to PPT.
So this is the gem server and as well as
No, no, no. Go to
app.
the architecture diagram. Yes, you increase the size, screen size.
Okay.
You have that video play button right here.
Okay.
Ah,
Okay.
yes. Now, two EC2s are running in public subnet, right?
Yes.
One you are using as a gem server in between public and private. This one, right?
Yeah. The app server is in between the public and private.
Hmm. Okay. Now, groups are created for three EC2s, right?
Yes.
Can you show the groups in console? What are the groups you planned it and created from the Terraform script?
Yeah. Security groups. You ask.
Yes, yes.
Yeah. For three servers. So one second. See security groups. So this is for app. So this is a gem security group, and this is the DB security group.
Hmm.
For the three, and we have seen already a VPC created as well as NAT gateway also created, and internet gateway is also created.
Okay.
We'll check.
Now check the command prompt. Script is done.
So almost 21 resources are added. Now we'll check whether actually our WordPress is installed in our web server public IP or not.
Oh, okay. Check that browser. That is the IP, right? Public IP. You can copy here also. I will also check from my system. Good. It is ready for configuration, right?
Yeah, I will share that.
Yeah.
So click on continue. So the
Yes, it
page
shows
is
admin, WP admin screen. Yes, good. So it is ready for configuration. Now you can configure manually and to show the blog site.
yes.
What are the manual steps you need to use? Do you have the slide for that? Can you explain that?
So yeah, so these are the manual steps from 1 to 10. So we'll go through one by one. So first we need to create VPC and subnets as a public and private, and as a route table public and private. So this is the step first one. Task 2, we need to associate subnets with the route table as well as route table with the private subnet.
Okay.
Task 3, we need to create internet gateway resource and attach to the VPC. So this is the manual pictures from the AWS console. So next we need to create an NAT gateway and it should be modified to the route table. So this is for NAT gateway and this is for edit the routes to the NAT gateway from NAT gateway.
Okay.
So we need to create security groups manually in the AWS console for the three servers. Uh, like gem server and app server and as well as DB server. And finally we need to install 3 servers, EC2 and app server as well as DB server. Next we need to set up the SSH key to log in to the apps and the DB server from the gem server. For that we need to set up the SSH key and we need to give permissions for that to log into the app and the DB server. So after login, we need to install MariaDB and we need to configure that server. So these are the steps, manual steps you need to execute in our DB server. So once we install all the things successfully, now we need to give access to the DB server from remote machine. Means so you can allow some machine, one machine to test whether it is working or not. So for that you need to install WordPress. So after install WordPress, you will check with the help of this command. So mysql -u wp user -h local db ip -p. So you can successfully log into the DB server with the help of application server. So from the app server, you should able to get into the DB server. But from the gem server, you can't able to reach to the DB server. So that is what I shows in the diagram.
Okay. So are you going to set up that now, WordPress, or in this demo, or later you will show?
So yeah, I'll show later. I will show.
Okay, fine. Let us stop the recording. It is good actually. You did Terraform demonstration very good. Scripts are very modular approach in a decomposed manner. You have done it. Scripts design good.